In this video, we're going to be talking about solubility equilibrium, or KSP. So you probably know this a little bit from last year, and you should have reviewed them for summer work, but basically what you need to know going into KSP is solubility rules. So essentially, you have to know different elements or polyatomic ions that are soluble or insoluble. So we know here from this table that all nitrates, chlorates, acetates, sulfates, chlorides, bromides, and iodides are always soluble, along with a few others. And insoluble are different metals like barium, strontium, calcium, silver, mercury, and lead. And you can see across the table here that if a sulfate's paired with a barium, then it wouldn't be soluble. So that's just something to know. And hydroxides are sometimes soluble when they're in strong bases, but other times they're not. So just review this because you don't get a solubility table like you did in Chem 3 on the test. So solubility. Soluble is defined essentially for example, is 3 grams of salt dissolved in 100 grams of water, and then it would be fully dissolved. But if only 2.9 grams are dissolved, the salt would be determined as insoluble. So sometimes solubility is a misleading term, and that goes into dynamic equilibrium, or KSP, which we're going to review with this chapter. So slightly soluble salts establish a dynamic equilibrium with the hydrated cations and anions in solution. So we're going to talk about a little bit about that now. So KSP is determined from experimental measurements in labs and stuff. So a lot of times KSP is given. So in this case, we have a common salt that we talk about a lot is AgCl. So AgCl solid has an equilibrium reaction and it dissociates slightly into Ag plus and Cl minus. So to determine the KSP of this salt, you have to multiply the concentration of Ag plus times the concentration of Cl minus. So sometimes this is given, but other times you can find this experimentally. So in this case, you would have plus x and plus x because the ratio is 1 to 1. But if it were to have a coefficient of 2 for 2Cl in a different salt, then you would have 2x, and you would have to square the ion concentration in the KSP equation. So solubility and the common ion effect. So the presence of a common ion, which is a substance that is included in the original salt, when that is put into solution, the equation will shift to the side of the salt because the ion will form a precipitate with its opposite. So for example, if you add a cation, it's going to form into the salt with the anions that are in solution. So eventually equilibrium will be reestablished, however. So Q and KSP, we talked about this a little bit with equilibrium, but if Q is less than KSP, that means there are more reactants. So the system is not at equilibrium, so it is unsaturated. If Q is equal to KSP, the system is at equilibrium, which we call saturated. And if Q is greater than KSP, the system is not at equilibrium. So that means it's supersaturated. So there's more reactants than products. So the reactants form more precipitate, which is called supersaturated. That's all. Thank you.